Good morning, friends. Now we'll start section 5, determination of need for a cathodic protection. API recommended practice 651 states that the need of cathodic protection must be determined for all storage facilities. Decision governing the need of cathodic protection should be based on all but which of the following: National Board and ASME recommendation, it is not needed. Data from corrosion survey and operating records, it is needed. Prior test results with similar system, similar environment needed. National, state and local code requirements and the recommendation of API 651 is needed, not ASME. When should corrosion control by cathodic protection for new ASTs is provided? In the initial design. Paragraph 5.1.1. Generally, tanks in petroleum services use coatings on the internal surface to control internal corrosion. Cathodic protection is an effective means of corrosion control only if it is possible to pass electrical current between what two components, anode and cathode. A full evaluation of tank history should be performed prior to determining the need of cathodic protection. 5.2.1. Sorry, can you just give me 1 minute? Sorry. Such items as site plans, soil properties, previous repairs, existing cathodic protection of nearby structures, maintenance history, and expected life should be investigated and determined when conducting the evaluation of tank design construction history. The following items, which is not an item that should be investigated and determined in the evaluation of types of service. Ambient temperature, not types of product stored, product temperature, presence and depth of water bottoms. These are all required. Such items as tank inspections per API standard 653, corrosion rate records, stray currents problems, design and performance of previous protection systems, and structure to soil potential surveys should be investigated and determined when conducting the evaluation of inspection corrosion history. Paragraph 5.2.3. The cushion material under the tank has a significant effect on external corrosion of the tank bottom. Material can also be influenced the effectiveness and applicability of external cathodic protection. So what is the advantage of using fine particles for the cushion material? Fine particles provide more dense cushion. and to help reduce the influx and outflow of the oxygen. But the main disadvantage in using large size particles in soil cushion material. If a large particle are used, differential aeration corrosion may result where the particle contact the tank bottom. Soil resistivity of about 1250 ohm cm would indicate the soil is probably moderately corrosive. So there is a table 1, it is written there, 1002 something. It is moderately corrosive. So you can go for this table 1. The result of soil resistivity surveys can be used in determine the need of cathodic protection. A properly designed concrete tank cushion constructed on a stable, properly prepared subsoil may be effective in all but which of the following? Cracks in the tank bottom weld seams. So it is not effective for that. Intrusion of groundwater, soil side corrosion, the need of cathodic protection is all effective. But for this, not effective. A5532. So crack through the concrete cushion may permit water and contaminants to permeate to the steel tank bottom and provide a path for protect proper electrical current flow. Yes, true. Corrosion of the steel tank bottom installed on the concrete cushion may result from moisture accumulation caused by all but which of the following: humidity in the air surrounding the tank. Why would it be more important to provide proper support under cushions of new asphalt than the concrete? Asphalt is not inherently alkaline and therefore doesn't have the potential of preventing corrosion. How can the condition of external surface of tank bottom when the asphalt cushion be determined? By cutting coupons from the tank bottom. A soil analysis reveals the pH of a native soil cushion to be 6.25. So it is between 5 and 8. So it is soil is considered to be mildly corrosive. So APRB 651 paragraph 5321. The soil analysis reveals the sulfate level of a native soil cushion is 5525 ppm. Soil is considered to be very corrosive. It is just 200 ppm is allowed. So if it is 5525 means it is heavily corrosive. What is the most common material used as a cushion beneath the storage tank bottoms? Clean sand. The use of oiled sand beneath the tank bottom doesn't eliminate the need for cathodic protection and is in fact may cause cathodic protection to be less effective because the oiled sand is higher resistivity. There are several ways the tank cushion can become contaminated. Three of the following are methods of cushion contamination. Which one is not? So in coastal areas, salt spray may also wash down to the side of the tank. Fertilizer from spraying operation in rural areas airborne chemicals from chemical industrial operations. But which one is not residual buildup of electrons in the sand cushion? That is nothing to do with this corrosion, contamination, tank cushion contamination. Linkage of product from tank bottom can cause isolated corrosion by creating corrosion cells where none existed before. So leakage of product is giving isolated corrosion. When layer of crushed limestone clumps or clump cell is used for tank cushion, why it is important to ensure the particles are fine and uniform. Differential aeration corrosion cells will cause pitting at contact areas between the large particles and the metal. So what is an advantage of using crushed limestone or clam cell on the tank bottoms? So water from the rain or groundwater makes the environment under the tank alkaline, which may reduce corrosion. Heated tanks and tanks storing hot products can cause isolated corrosion on the external surface due to elevated temperature if the area is wet. There are variety of methods for secondary containment, which the following is not an accepted method for secondary containment. Sandbags, dual bottom tank design, yes, use of impervious clay paired in tank dike, impervious non-metallic membrane. Impervious means water will not go inside. Non-metallic membrane, if it is going through, then problem. During the installation, we use steel bottom over the existing steel bottom, which has been actually paired. If water or the other electrolyte intrudes into the annulus, what can happen? A galvanic shell may form, which will cause the new steel tank bottom to corrode at an accelerated rate. With the installation of a secondary containment system utilizing an impervious membrane in a diked area prior to new tank construction, most cathodic protection systems are rendered ineffective. We have to read this really. This book is good for getting more information. As many questions I am getting, I'm giving you. Thank you, Yanpen. So 3 chapters finished.